This is the lecture for lesson 8. The first part of this lecture is going to talk about solving linear equations with one variable. So we will talk about identity, conditional, and inconsistent equations. We will then solve equations where a variable is on one side and when the variable is on both sides. Before we can actually solve equations, we have to talk about the different types of solutions that we can get. The first type is called an identity, which is going to be true for any value that you plug in. The only way that this is going to hold true is if what is on the left-hand side of the equation is going to equal what is on the right-hand side of the equation. You may not see it right at the beginning. You may have to do a little bit of work, but if you do some work and get to a point where what is on the left equals what's on the right, or you get a true statement like 4 equals 4, that is going to be an identity statement, and you can plug in any value and it's going to work. Conditional equations are the ones we're going to see the most often. These are the ones that are going to have a single answer. So you will go through and solve, and you will get x equals an answer or y equals a number. Do know that 0 is in fact an answer. So if you get x equals 0, that is a conditional, that is a solution. The last one is called inconsistent. Inconsistent is going to yield us a false statement where the left-hand side cannot ever equal the right-hand side. And what we're going to state is there's no solution. And it looks like right here, this bottom line should say -5 equals 13. So what you have is the x piece ends up being the same, but then what you do with the x piece gives you something different. So I can't take x minus 5 and also take x plus 10 and get the same answer. It's physically impossible. So that is a false statement or an inconsistent equation. These first problems are just asking us which type of solution is it? Is it an identity, a conditional, or an inconsistent equation? Remember that identity is going to be exactly the same on both sides. Conditional, you're going to end up with x equals something. Inconsistent is when the x pieces are the same on both sides, but the number is not. So you end up with a false statement. Let's do a little bit of simplifying with this first one. On the left-hand side, it's 7x plus 5. Now let's work with the right-hand side here. Let's distribute that 5 out. So 5x plus 15 plus 2x. And if I simplify that, I've got 7x plus 5 equals, on this side, 7x plus 15. So this can't ever be a true statement. There's no way to take 7 times a number and add 5 and do 7 times that same number and add 15 for them to be the same. So this is inconsistent. This one will not work. Next, for B, this is a problem where I could move the x term from one side to the other. And the way we do that is always with opposite operations. So if this is a positive 2x here and I wanted to get rid of it, I would subtract 2x from both sides, because what you do to one, you must do to the other side. I now have 2x plus 7 equals 7. I am going to be able to solve this. I can keep working here, subtract 7. 2x equals 0. This again is a true statement. The way that I can get 0 here is if x equals 0. 2 times 0 is 0. So these two equations will equal each other when x is 0. This is a solution. So this is conditional. Which, if you follow along here, you're probably going to guess that this next one is going to be the identity. But let's check it to be safe. So let's distribute that -3 out. So I've got 3x. That's going to make -6 plus 3x. And then on this other side, distribute the 6 out, 6x minus 6. Simplifying what's on the left-hand side, 3x plus 3x is 6x minus 6 equals 6x minus 6. They are exactly the same. So we do, in fact, have the identity here. Determine whether the following statement is true or false. If the statement is false, then make the necessary changes to make it true. They are stating that negative 7x equals x has no solution. So they're stating there's no way to plug in a number for x such that they would be equal. Well, I'm going to say that this is false, because I can make these two statements true if x equals 0. Because negative 7 times 0 is 0. And on the right-hand side, if x is 0, then they are, in fact, equal. So this equation does have a solution, x equals 0. Next one wants you to write 3 equations that give you a solution of x equals 4. So think about it here. If we know x has to be 4, so let's say, pretend 4 minus 1 would be 3. So x minus 1 has to equal 3. We could say 2 times x. Well, 2 times 4 is 8. So 2x equals 8. That would work. I could take x representing 4, add 2 to it, and that would equal 6. All 3 of these would give me x equals 4 as the answer. So let's go ahead and solve a few of these. We have 3x plus 5 equals 41. Remembering that our goal is to get to the variable by itself, and we have to do that by opposite operations. If I have 3x plus 5 equals 41, I want to get x by itself. The first thing I need to move is the plus 5. The way I do that is subtracting 5, and if I subtract 5 from one side, I must subtract 5 from the other side, leaving me with 3x equals 36. Now, 3 and x are written right next to each other, which means that they are being multiplied. So in order to undo multiplication, I am going to divide. And if I divide the one side by 3, I must divide the other side by 3. So the final answer here for A is that x has to equal 12. We'll do the same thing with B. 25 minus 6x equals negative 83. Right now, this is the x piece. I need to get rid of this positive 25. So to get rid of positive 25, I'm going to subtract 25 from both sides, leaving me negative 6x on the left and making negative 108 on the right. Now the negative 6 is attached to the x with multiplication. So to undo that, I'm going to divide both sides by negative 6. And when I take negative 108 divided by negative 6, I get the answer 18. Moving on to problems with a few more steps and variables on both sides, we are going to have a little more work. So looking at this first one, what I'm going to do here, I've got a 3 that's got to be distributed. I have a negative 2 that has to be distributed, and I have a 5 that has to be distributed. So I'm going to pull that over here. 3 times 2x is 6x, minus 3 times 5 is 15. Then I do negative 2 times 4x, negative 8x. Negative 2 times 1 is negative 2. Equals 5 times x is 5x, plus 5 times 3 is 15. And then there's a plus 2 on the end. I am going to combine the like terms that I have on the left side and separately, and then do that on the right side. So 6x minus 8x is negative 2x. Negative 15 minus 2 is negative 17. And then on the right-hand side, I have 5x plus 17. Now, personally, for me, I like to get rid of negative x's. So I will bring my x's to the right-hand side. So I want to get rid of negative 2x. So what I'm going to do is I'm going to add 2x to the other side here. I'm going to get negative 17 equals 7x plus 17. Now I'm keeping the 7x here and I want that 17 to go. So how do I get rid of plus 17? I'm going to subtract 17. Negative 17 minus 17 is negative 34 equals 7x. And the last step to get x by itself is going to be to divide by 7. So in this problem, negative 34 sevenths equals x. x. B is similar. It has a little bit of distribution here, but please, there should not be a z on the end there. It should just be a 4. So 6x plus 1. I'm going to distribute that negative in. So negative x, negative times negative is going to make positive 5. And on the right-hand side, we're going to have 2x minus 4. Just like the last problem, I'm going to combine the like terms that I have on the left-hand side. 6x minus x is 5x, and 1 plus 5 is 6. And on the right-hand side, I still have 2x minus 4. I'm going to move the smaller of my x's to the other side. So positive 2x, I can get rid of it on the right-hand side by subtracting 2x, which means I then have to subtract 2x on the left, giving me 3x plus 6 equals negative 4. To get the x piece by itself, I need to now get rid of the plus 6. So I'm going to subtract 6. So I have 3x equals negative 10. And the last thing I'm going to have to do is divide both sides by 3 to get a final answer of x equals negative 10 thirds. And our last problem is 8x plus 1 equals x plus 45. So again, I will always move the smaller of the x's, which is a 1x. So I will subtract it to the other side. 7x plus 1 equals 45. Now I need to move the 1. So subtract 1 from both sides. 7x equals 44. And now to get x by itself, I'm going to divide both sides by 7. The final answer is 44 over 7. So sometimes you will get nice round answers like you had on the first problems. We got x is 12 and x is 18. And other times we're going to get fractions. Both are okay. Now the next part about working with equations is being able to create the equation from a word problem. So reading a word problem, turning it into variables and numbers, and then of course solving that problem. First problem says, Ashley is choosing between two gyms. Gym A offers a membership fee of $40 plus a monthly fee of $25. Gym B offers a membership fee of $15 plus a monthly fee of $30. How many months will the total cost at each gym be the same, and what is the total cost for each gym? Well, Gym A is $40 plus $25 per month. So Gym A is $40 plus $25 each month, so 25x. Gym B is $15 plus $30 each month, or 30 every x every month. We want to determine after how many months these will be equal. So I'm going to set these two equations equal to each other and solve them. I will move the smaller of my x's, which is 25x. So I'm going to subtract 25x. So I have 40 equals 15 plus 5x, which means I now need to get rid of the 15. So I'm going to subtract 15 from both sides. I get 25 equals 5x. And last, I'm going to divide both sides by 5 to get an answer of x equals 5. Remembering that x was our months. So 5 months and the 2 plans, gym memberships, will be equal. We now want to figure out what will the total cost be at those 5 months. So I just need to plug that 5 back into one of my 2 equations. It doesn't matter which one. So if we go 40 plus 25 times 5, that's 40 plus 125 is going to give me $165 that I've paid for my 5 months both of the gyms, either of the gyms will both be $165. Number 2, an auto shop charged $262 to repair a car. The bill listed $82 for parts and the remainder for labor. If the labor is $30 per hour, how many hours of labor did it take to repair the car? Well, anytime you see that per hour or per month, that's where your variable is going to be. So it was $82 for parts plus $30 for every hour, X, and the total was $262. So once we got it set up, we're going to solve. I'm going to subtract 82 from both sides. I have 30x equals 180. Then I need to divide by 30 to get x equals, 6, not 66 hours. And that is all it asks for. How many hours did it take to repair the car? 6 hours. Number 3, the larger of two numbers is equal to 3 times the smaller. So let's write that first. So we have two numbers. A small number, we're just going to let be x. The large number is equal to 3 times the smaller. So the larger number is 3x. All right, so if we read, if twice the larger, so if 2 times the large number, or 2 times 3x, is added to 3 times the smaller, 3 times x, the sum is 27. So that means the result is 27. What are the two numbers? Well, let's figure it out here. 2 times 3x is 6x, plus 3x equals 27. Adding my like terms, I have 9x equals 27. And if I divide both sides by 9, I get x is 3. So the small number, which is x, is 3. The larger number is 3 times that, or 9, is the larger number. Number 4, 3 times a number, so 3 times a number, that's 3x, is added to 4 times that number, so plus 4x, equals 84. Find the number. Well, 3x plus 4x is 7x. It's going to equal, 84, not 8x. Then I'm going to divide both sides by 7 and get the answer of 12. Okay, number 5, if 6 times a number, so start with 6 times a number, or 6x, is decreased by 14, you subtract 14, the result is 124, so equals 124. In order to solve this, I'm going to first add 14 to both sides. I get 6x equals 138. And when I divide by 6 on both sides, I get the answer of 23. Number 6 and 7 are going to ask about the perimeter of a rectangular space. So in order to know that, we need to talk about the equation for perimeter. So perimeter around a rectangle, so a rectangle has a width, a length, and a length. So perimeter is 2 widths plus 2 lengths. Let's look at number 6. The length of the rectangle is 4 more than twice the width. So if I'm thinking about that, the length, this piece here, is 4 more than, or 4 plus twice the width, so 2w. Okay, that means this side is 4 plus 2w. That means this side is w and that side is w. We have our rectangle. We can find our perimeter. You can do this one of two ways. You can use this equation and do 2 times the width plus 2 times the length. The length is 4 plus 2w's. And set that equal to 44. Or you can look at your rectangle and just combine everything we have here. So 1w plus 2w's, 3w, 4w, 5w, 6w, plus, and then 4 plus 4 is 8, is going to equal 44. You're going to get that same answer if you do this multiplication out here. You should end up with 6w plus 8. What I'm going to then do is subtract 8 from both sides. I have 6w equals 36. So when I divide both sides by 6, w equals 6. So it says, what are the dimensions? Well, the width is 6, but now we need to go back and find the length. The length is 4 more than twice the width. So twice the width is 12. If I add 4 to that, the length is 16, and both of these are centimeters. Number 7, the length of the room. So if you want, you can draw it again. The length of the room is 6 feet longer than twice the width. So the length is 6 more than twice the width. 6 plus 2w. Means the bottom is 6 plus 2w. It means the width is just w because we are determining length in terms of width. We know that the entire perimeter is 168 feet, and we want to find our dimensions. So again, you have the option to do 2 times the width plus 2 times the length, 6 plus 2w, and that's going to equal 168. Or you can look here and say 1w plus 2w's, 3w, 4w, 5w, 6w, plus 6 plus 6 is 12, equals 168. He will then solve, subtracting 12 from both sides. 6w equals 156. If I divide both sides then by 6, I will get my width is 26. And this one is feet. And then I need to plug back in to find my length. My length is 6 more than twice the width. And if I do that, I end up with 58 total, because 2 times 26 is 52. Add 6 more. 58 feet is the length.